This video is brought to you by Lenka from Newton Technologies. Automatic Speech Recognition. Chapter 1. It's a kind of magic. Automatic Speech Recognition, or ASR, is a magic way of converting sound into text. As you are probably aware, sound is nothing more than vibrations of the air that we humans are trained extremely well to decode. And now we are teaching our computers how to do this. So let's strip away some of the magic. In the beginning, we have a stream of words that a person has uttered. The sound is picked up by a microphone and through a sound card converted to digital signal that means a stream of ones and zeros. This by itself is pretty fascinating magic too, but I won't go any deeper into this today. Afterwards, the ASR algorithm does its thing and the words appear written on your screen. The first step the ASR system needs to do is process the sound. More magic happens here that I won't be delving into, but the goal of this step is to have chunks of speech that can be worked with and that can be mapped to letters. Let's call these chunks phones. The fancy term you can also hear is phoneme. I'm obliged to say that there is a difference between these two terms, but their usage in speech technology is not consistent, and the only ones that really like to argue about this are the linguists, so let's leave it to them, well, to us. The part of ASR responsible for mapping sound to phones is called the acoustic model. You can imagine the acoustic model as a set of building blocks, boxes, which contain models for all phones in a given language. There are boxes labeled A, B, C and so on, depending on which phones are used in the particular language. On top of that, part of this construction set are also contextual probabilities. This means how likely a phone is to follow another. So, let's imagine that I said, "Hello, my name is Lenka." This is the rendition of the sound wave that my mouth produced when I spoke. The task of the acoustic model is to guess which phones I pronounced and how do they combine to a word. The acoustic model processes the sound and compares it to the models of individual phones from its boxes. Most likely, since speech is very complex, the chunks that I uttered will be similar to more than one box. The acoustic model takes this into account and also looks at the neighboring chunks and their contextual probabilities. For example, the first sound that I uttered might have been h, but it also could have been ch. The second sound looks most like e, but it also could have been a, or even e, with different degrees of certainty. The next sound is probably l, but also could be r. But there are different probabilities of these phones in context. H followed by e is more likely, at least in English, than h followed by e, etc. The more frequent combinations are given priority. The ASR system combines these bits of information and outputs the most likely result, a string of phones. Okay, so we have our most likely string of phones, and the next step is to convert it into words. But this part can be tricky, because the ASR does not know when a word starts or ends. Contrary to popular belief, there are no pauses between words in fluent speech. This particular string of phones can constitute several different phrases. I could have said something like, "Hello, my name is," or "Hello, my name is," or "Hello, my name is." So, which one is it? The part of ASR responsible for mapping phones to words and phrases is called the language model. You can imagine the language model as a huge table that contains the probabilities of two words following each other. In our case, the language model looks at these possibilities and determines which combinations are the most probable ones. Since "hello, my name is" a fairly common phrase, in contrast to the others, chances are that the ASR system will evaluate it correctly. In the next chapter, we'll talk about where it all comes from. This means training of the models.